Welcome to part 2 of our notes on erosion. And in parts 1, we took a look at a good definition for what erosion is. And erosion is the process that moves sediments from one location to another. Remember, weathering is the breaking down of rocks into sediments, and erosion is what moves the sediments. And in part 1, we took a look at what erosion is, and we took a look at gravity's effect on erosion, as well as the wind's impact on erosion. And now in this part, we're going to take a look at running water and what running water has to do with erosion. And when it comes to us here in Wisconsin, running water is a very important form of erosion. We don't have the steep cliffs, the tall mountains to get a lot of gravity causing erosion. And wind, we'll have some wind every once in a while, but running water is really what's going to form a lot of our features today. So running water is the most important form of erosion in Wisconsin today. Now here's Three Chimneys here in Westby, Wisconsin. Again, water probably had a lot to do with the formation of these geological features. You look at something such as the Grand Canyon. You got the river running through the bottom of it, the Colorado River. And again, when you look at the just pure awesomeness of what that river did and what it carved out, if you've ever been there, you know that water can move a lot of materials if it's given enough time. Now, you might look at this and say, well, I don't recognize this feature. Anybody recognize what some of these things are? For example, this right here. This is actually a road. You can see where the road was built up here. And the reason I'm showing this picture, after we had our last series of flooding here in Wisconsin, I took some of these pictures. This was a culvert, and this culvert might be, have a 4-foot diameter, and that culvert was more than enough to handle any of the water that had gone through here in years and years, even back in '93 when we had the major flooding in Wisconsin. This culvert could handle all that, but with the most recent round of flooding a few years ago, this culvert was completely wiped out. The water was moving through here so fast, the water started to erode away at the edges around here, and eventually it took out this entire road. Now, sorry about that, I just want to see if there's another picture. So you can see the road right here, and you might have a 30-foot drop down. So within a day or two, this entire road was taken out by running water. So you can see running water can play a huge role in the movement of the sediments. In other words, in the erosion of sediments. It can move a lot of material, and it can move it very fast. Now, how much a river can erode is really dependent on the energy of the river. The amount of energy a river has is determined by two factors. One, its velocity, and the second is its volume. Now, a lot of times these will go hand in hand. Typically, you got a lot of volume, the water may be flowing faster as well. But when we took a look at the last round of flooding we had here in Wisconsin, it was just the pure volume of the water. There was just an overwhelmingly a large amount of water. And a lot of that came from the large amount of rainfall that we had over the course of not only a few days, but several weeks, because the ground was saturated well before we had this latest round of flooding. Now, volume is the amount of water running across the land. And you typically, if you add volume, you're going to get more erosion. So I have plus signs here. And what that's meant to show is that if you add volume, you also add the amount of erosion. Or if you subtract volume, typically you're going to have a decreased amount of erosion. Now, velocity is the rate at which water moves. And same thing with these plus signs and this negative sign. If you typically add velocity, you're going to add erosional forces. If the water is moving slower, in other words, if you decrease the velocity, typically you decrease the amount of erosion. Now, the energy of a river enables it to do work. And the river uses this energy to do several things. One, it's going to overcome friction. There's always going to be friction between any moving material, whether it's wind, whether it's water. There's going to be friction. So the energy of a river enables it to overcome this friction between the water and the river channel. And the energy of a river enables it to start to erode material. It starts to move away material from the river banks and from the river bed. and it also allows the river to transport material. So yes, you're eroding it from the riverbed and banks. So where are you taking the material? Well, it's going to move it downhill. A lot of times you can think of a river, if it's going to have a job, its job is to erode material. Its job is to move materials. Now, a lot of times we as people will use that, and we will put barges on major rivers, we will put boats on rivers, and we use it to move materials for us too. But the river is also moving the silt, the clays, the sand from the river as well, and sometimes even large materials like rocks and boulders. Now, the erosional work of a river really depends on the volume. Now, how do we calculate its volume? How do we figure out how much volume it has? One, look at the size of the drainage basin. The larger the basin, the larger the amount of water that will flow into the river after an event such as a rainstorm. Presence of vegetation. Vegetation tends to slow water down, and because it's slowed down, it also has more time to soak into the ground. So if you have more vegetation, you tend to have less of a volume. And the permeability of the rocks. If the rocks are readily able to absorb that water, in other words, take it up into the ground and become part of the aquifer, you're going to have less volume. But if the rocks don't hold water or are impermeable and don't let water flow through them very easily, you tend to have more volume because there's no place for the water to go. And obviously the climate. If it's going to have a really dry, arid climate, you tend not to have a lot of volume because you tend not to have a lot of water. But if you're constantly having rain, say in the rainforest, you tend to have a large volume because you tend to have a lot of rain falling, a lot of water. So the erosion work of a river also depends on the velocity. Well, what kind of things go into velocity? Obviously, river gradient, the slope. The larger the slope, the steeper the slope, the more velocity you're going to have. Channel roughness. If you look at the bottom of a river, if you look at the sides of the river, if there's all kinds of rocks in the bottom of the river, you might have trees falling in the river that were on the side of the river. If you have all these obstacles, they're going to slow down the water. It's not going to flow as fast. The channel shape. What kind of shape is it? Is it going to be a very broad river? So if I draw a picture, is it going to be a river that's going to be very broad like this, where there's a lot of room for friction? Or is it going to be more of a deeper river where there's less friction because there's less surface area that the water is coming in contact with? Now, how a river erodes a curve. Water will always travel towards the outer bank of the bend with a great velocity, and it will erode it, and it will deposit that material, the eroded material that it moved, it will deposit on the opposite side of the bank. Sometimes this is called the inner bank, where friction between the river water and the inner bank is great. So again, water travels towards the outer bank of the bend with great velocity, eroding it and depositing the eroded materials on the opposite inner bank, where friction between the river water and the inner bank is great. So let's take a look at this. So the water wants to go in a straight line. Doesn't want to move. So it's going to come straight here. And this is called the cut bank. This is where it's going to erode away. If we can get this pen working again, this is where it erode away. So where's that water going to go? Well, what it's going to do is it's going to come here now, and it's going to go in a straight line again. And it's going to erode right here. And where's that water going to go? It's going to bend here, and it's going to go in a straight line. And so water is constantly pounding up against here, creating something called a cut bank. And out here, it's going to erode as well. So this is called the cut bank. This will have something called the slip-off slope. This is called the inner bank. This is called the outer bank. So the inner bank is where you're going to have most of the erosion taking place. The outer bank is where you're going to have less erosion taking place. So here we can see over time a steep cliff forms on the outer bank called the cut bank, and a gentle slip-off slope is formed on the inner bank. So it's hard to tell which way the water is flowing here in this picture, but either way you can tell that here it's coming like this. I mean, even if it's coming the other way, this is going to be your cut bank. You can see how steep this here. So they probably had some major volume coming down this river at some point in time. So there was probably some flooding going on, and it's cutting away here. But look at the inner bank I'm sorry, look at the outer bank right here. You see how low it is? Well, that's because a lot of this material that gets eroded away here gets deposited on these banks. So at one time this river was probably a lot straighter, but over time it's going to keep getting more and more curved as it keeps eroding away, and more of that material is going to be deposited here. So this will just keep coming off further and further and further. So here we see a really good example of a cut bank, where you can see the soil layer right here. You can see the grass. You can see that several trees used to be growing right here on the side, but now they've fallen off into the river. So you can see that the water is just pounding up against here, and a lot of times it will cut away down below here, and eventually this whole piece will fall off into the river. Now, the transportation of load. And the transportation of load. When we talk about a load, and a load is what a stream carries. Now, there's several different types of loads. One, there's the dissolved load. This is your dissolved rock. This is material that's actually dissolved into the water. This may be a lot of minerals, especially if you say you have a limestone bedrock, things that are actually dissolved into water. You're going to have the suspended load. These are things like your finer sediments, usually your clays, your silts, could be sand. And this is what's going to a lot of times give your river that dark color. If you've ever noticed that after a lot of rain, the water seems to be really brown, and a lot of people say, oh, it's really dirty, it's not a clean river. Well, it's clean, it's fine, it's just it's got a lot of suspended material right then, because if it's after a rainstorm, the volume is much greater, so it can carry a lot more material. Typically when it's drier out and the streams are way down, the water tends to look more clear. That's because it doesn't have that energy to move a lot of this material. And then we have the bed load. This is your coarser sediments. This could be your heavier sands, your gravel. And these things tend to slide or roll or skip along the small or the bottom of a stream bed. So here we see some of those same words that we saw when we were talking about wind, where we were talking about your bed load. Here you have your saltation, where it'll pick things up, move it a little bit, and then it'll drop it again, pick it up, drop it. You have your dissolved load, you have your suspended load, all in this water at the same time. So obviously the more volume it has, the more material it's able to carry. Now, deposition. When a river loses energy, some or all of its load is deposited along its channel. Heavy material is deposited first, and that makes sense, because if it starts to lose energy, the heaviest materials, the material that it's using the most energy to move, is going to be the material that it's going to drop first. Now, deposition occurs when A, when water slows down, B, when a river enters another water body. And if you think about this, when water enters another water body, it's going to do what? It's actually going to slow down. It'd be like if you're on the highway traveling, 65 miles an hour, all of a sudden you come up to a traffic jam, you have to slow down. So the water here is doing the same thing. As it's going into a river, the river is flowing, and as it empties out into, say, a lake, the lake is not moving, so the water slows down and it has to drop a lot of its load. Now, before I go any further, I've used the word river a lot, and one of the common questions people ask me is, well, what's the difference between a river and a stream? I hear people talking about a stream bed. Well, streams are just generic terms for rivers and creeks. So if you ever hear the term stream, it's just a generic term out there, and you could, there's really no set definition for it, but typically most geologists will refer to things as rivers and not necessarily streams. And so let's get back on task here. Deposition also occurs when there is more friction in the channel. So maybe there was a storm and a bunch of trees fell off into the river. Ultimately, that's going to cause a lot of deposition because water can't flow as fast through all this material. So what we're going to do today is we're also going to talk about a few river terms. Now, you see all this bending going on here? This is actually the Baraboo River as it flows finally into the Wisconsin River here. Now, first of all, these bends in a river are called meanders. So meanders are curves and bends along a river. Now, Oxbow Lake. An oxbow lake. An oxbow lake is a crescent-shaped lake formed when a meander becomes so pronounced that it's cut off from the main river. And you can see some of that right here. So you can see this right here. You can see one right here as well. So what had happened at some point in time is the river probably came up through here somehow, and what it does is it keeps wearing away, eating away right here, eating away right here, and eventually what happens is it comes around and wears away. Eventually it just works right through. And eventually it actually went down and around here too. So they created oxbow lakes, and if it's considered an oxbow lake if water stays in it. Now, it might be considered an oxbow swamp or an oxbow scar if there's no water in it anymore. But a lot of times, as you can see, what happens is the water comes through, it's eroding away right here, and eventually, and as it comes through here too, it's eroding away. Eventually, this gets to the point where the water can just go straight through. And if there's water there, it's an oxbow lake. If it's starting to fill in with debris and plant material, it's an oxbow swamp. And if there's nothing in there, a lot of times they just call it a meander scar or an oxbow scar. Sheet erosion is when water runs over the land and erodes without being in a stream channel. So if you had a lot of rain, this happens first, where it's just like a wall of water going over the surface. It's just everywhere. Now eventually it's going to do some erosion. It's going to move some materials, and it's going to start to form small channels called rills. So no one would call this a river by any stretch of the imagination. But as the water flows through it, it's making these channels, and they call these rills. Now eventually rills can deepen and they can widen and they can become gullies, and that's how you get gully erosion. These are deeper channels created by running water. And eventually, if water would flow nonstop over it, they would call them rivers or creeks. Now, a waterfalls are simply vertical drops in a stream. And Niagara Falls is probably the United States' most famous example of a waterfall. Now, here's an interesting fact about the Niagara Falls. There's actually two parts of the falls. There's the horseshoe-shaped Niagara Falls that most people are familiar with, but there's also part of the falls called the American Falls, and they've actually shut that off. And a lot of times I'll tease the kid and say, yeah, they can just stop the water from flowing, and they can just turn a switch and it just stops. And oh, really? Well, what they actually did was they dammed it up at one point in time, and they actually built a hydroelectric dam across here. So by doing it that way, they're actually able to harness the energy of that flowing water. So they have turned it off in the past. And the interesting thing about it is you can actually see all the talus. And what happens over time is the water keeps flowing. What it does, it'll undercut this, and it'll wear away. And so eventually these break off, and eventually this just keeps receding back. So over time, eventually Niagara Falls and American Falls would just keep working back further and further and further. So what they've actually done is they've actually controlled the amount of water that goes over the dam or over the waterfall so that there's not as much erosion taking place. Now, floodplains. A floodplain is a wide and flat plain built up by alluvium deposited by the river after repeated flooding. So if you can imagine, this is a river. And typically, most springs, a river will flood. And as it overflows its bank, it takes a lot of fine material with it, a lot of silt, a lot of things that are really good for growing crops. And so what it does is it builds up a natural floodplain. Now, unfortunately, we as humans, we also like to build there, and that's why when you have a natural floodplain, if there's a river, when you're building a house, you should always look and see where the natural floodplain is, and try not to build in that floodplain, because you know you're going to have flooding. Now, does flooding happen there every year? No, maybe not. It may not happen for decades and decades, but every once in a while, you're going to get a large enough amount of rain where you're going to flood. It's going to flood its bank, and if you had built there, your house would be flooded. So here we can see some natural floodplains. You can actually see some natural levees building up. So a lot of rivers have natural levees. So as the water overflows its bank and it starts to slow down, a lot of deposited material gets deposited right next to the bank, and this creates some natural levees. Now, a lot of times we as humans, we will build not natural levees, but unnatural levees or human-made or man-made levees to control water. Now, a couple things with levees. One, people get a false sense of security building behind it. And they'll think, well, I'll build over here. There's a levee. It's going to protect me. but if the levee breaks, all that water is going to come out and it's going to flood the area. Now the second problem with levees is a lot of times it'll break upstream and then the river is going to flow down here, but as the water starts to recede, because there's a levee here, there's no place for the water to go back into the stream, so it's actually trapped out here as well. And deltas. A delta is a flat piece of land made up of layers of sediments deposited at the river mouth over a period of time. And the delta typically has that, delta shape, that triangle shape. And a lot of times this is going to be very fertile land, and you're going to see these at the bottom or the end of rivers. So here is the Mississippi River, and you can see that all this sediment. So some of this sediment may have flowed down the Baraboo River. From Baraboo may have flowed into the Wisconsin River, which flows into the Mississippi River, which probably is being deposited right here. So some of that new land that's being created down in Louisiana may have come from Sauk County. That does end part 2 of our notes on erosion. Again, as we get back into class, if you have any questions about any of the slides or any of the notes that we've taken, please ask all the questions you want. And thank you.